Hello everybody, I'm Dan. Welcome to my Java tutorial series. Throughout my tutorials I will teach you Java using just Notepad and the command prompt. The order in which my tutorials are organized on both my website at javacjava.com and my YouTube playlist is designed to maximize learning by building on concepts from prior tutorials. This tutorial is about the AddAll method in the ArrayList class. I'm going to open up my web browser here to my website, javacjava.com, select Begin. I'm going to scroll all the way down here to my ArrayList addAll method. The addAll method is very useful for appending and inserting various array lists into the current ArrayList instance. Now there are two overloaded versions of the addAll method here. The first version has only one parameter and it appends a collection object to the end of the current ArrayList instance. Okay, so you can see up here, we've got the addAll. It has a Boolean return type, and then you've got this one parameter here. And this syntax can look especially confusing if you don't know what it means, right? And so I'm going to go into kind of breaking this down here. Now the second one just has the first parameter here is just a regular int index. And then of course the comma separates all parameters in here, and then this is the second parameter here. So the documentation syntax for the parameter list, collection and then diamond syntax right here, then inside of there question mark extends E, and then C is basically the reference variable there. It would be the local parameter variable, but it's always going to be a reference variable, so that may appear somewhat confusing. Now there are three parts to the documentation for this one single parameter. The first part is the class or interface, in this case the collection interface. And the third part is the local parameter variable, which will always be a reference variable in this case. So let's simplify things with a comparison. So take for example if we had a method named myMethod and then a single parameter string s. Well, we know this takes a string object and the s is the local parameter variable which points to the string object. Okay? If we had myMethod along the same lines, myMethod collection C, where I've gotten rid of this confusing looking syntax, the generic syntax up there, collection C. So this would be taking in a subclass slash subinterface reference of the collection interface, and C is the local parameter variable which points to a subclass object derived from collection. Now that may be real confusing, but I guarantee by the end of this tutorial you'll understand what that means. Okay, so the basic difference is that string, we know string is a class, right? Now collection is not a class. Collection is an interface, right? And collection has all these sub-interfaces here too as well. And pay special attention to this list sub-interface right here. It's going to come into play here, right? So list, if we click on it, you could see that public interface list extends collection. So let's go back to my thing here real quick there. So now the second part, which is inside the diamond syntax, we got question mark extends E, is generic syntax, and it means that we can specify a type variable and all elements of the array being passed in will be E or some subclass of E. Okay, now this will make sense here by the end of the tutorial too as well. So I briefly discussed the collections framework in my ArrayList constructors tutorial. ArrayList implements the very widely used list interface. The list interface in turn implements the collection interface, which explains the inheritance hierarchy between ArrayList and collection. Okay, let's come back over here. So collection, we click on list, right? You can see that list implements collection. Now you'll notice that we have an implementing classes here. So ArrayList is a subclass of interface list. So click on ArrayList, right? You can see public class ArrayList, extends abstract list, implements list. Don't worry about all this other stuff in here for the moment there, but basically we're just following up the hierarchy. So list is a super interface of ArrayList, and collection is a super interface of the interface list. Okay? All right, so I won't go into too many confusing details at the moment, but just understand that we can pass a list type reference as an argument because the list is a sub-interface of collection and a super interface of ArrayList. All right, so let's come down here. This very first statement, I'm just declaring and initializing a good old ordinary array there, right? call it sArray is the name of the reference variable, and it points to an array that contains all these string objects. Okay, so the next statement is critical here, right? We've got list, and we know list is a sub-interface of collection, right? So this is perfectly valid syntax here, because we're going to be basically passing in what we create right here into our AddAll method down here. Okay, so the next thing we got here is basically diamond syntax, question mark extends e. So in here I have string, the string class in there. So that basically means that this particular list, this list will basically only be able to take string or any subclasses of string. Now string is immutable, so it doesn't have any subclasses, but in the source code below I'll be using some other classes that do have subclasses and show you how all that works. Okay, and then of course list is going to be the name of our array. Now I'm going to set that equal to arrays, and I went over arrays very, very briefly in a few tutorials back there, but arrays is a very popular class. It's been around since like almost practically the beginning of Java here, but it has this one method here called asList, and that will take an ordinary good old array, and which is what the arrays class is really good for, is just basically good old arrays doing stuff with them. This asList will take a good old array and it will return back a list type, right? Okay, and basically since it returns back this list type, once again list is a sub-interface of collection, so we can pass the AddAll method a list type array object derived from the collection thing there. Anyway, so what we want to do here on the next line is go ahead and create a new array list, call it myList, and of course I'm using the generic syntax specifying we're only going to allow string objects in there. And the first thing I'll do in there on the next statement is just use the add method, which I went over in the previous tutorial, and add this one single string into the string object into the myList. So at that point it only contains one element there. Now I'm going to invoke the AddAll method here, and I'm going to pass it the list, right, that we created up here. And then what that does is that'll just append it all onto the end. So now the list will basically contain, if we were to display this to print line, it'll contain all this, some of my favorite states, and then Alaska, Colorado, Kentucky, Ohio, Texas, Vermont. All right, let's keep moving on here. So the second version of AddAll takes two parameters. The first parameter is the index number to insert the collection compatible array at. The second parameter is a reference variable to the collection compatible array. So building on the ArrayList instance from the example above, I will demonstrate how to insert the parameter array. So myList at this point currently contains this right here. Now I'm going to do myList.addAll, and I'm going to go to index number 3. So for example, this is index number 0. It always starts out at 0. This is 1. This is 2. And Kentucky is 3. So we'll actually insert it right before Kentucky is where that'll insert this new collection compatible array. Now you'll notice that for the second argument, instead of basically creating this whole list dealy-boppery up here, I just went ahead and put the arrays as list right in there. There wasn't any point in, creating, a new reference and so on and so forth. We can just put that right in there, okay? So I'm going to insert that between Colorado and Kentucky. And then if we display that to the console, it'll now display, this right here. So you can see right after Colorado here, we inserted Delaware, Florida, and Hawaii. And so that's how we got our new list there. All right. And I'm going to be going over bunch more stuff here down in the source code here. So let's come down here and highlight all this. Control-C to copy, or right-click and select copy. Let's move the browser off screen. I've got a shortcut to the command prompt on my desktop, but if you don't, you can create one really fast by right-clicking, selecting New Shortcut, CMD, next, finish, and that's all there is to that. Let's go and open it up, type in javac, which is the Java compiler command. Hit enter. You should see all this stuff scroll by. Now, however, if you receive an error message, watch my tutorial on installing the Java Development Kit. I want to make sure you get that installed and configured properly before continuing. CLS to clear the screen, CD space /, CD is short for change directory, / tells it to go to the root. I'm going to make a directory with the MD command called Java, and I already have that folder, but if you don't, you can, it'll create one for you. Change directories to the Java folder, and make a directory here called ArrayList addAll. Okay, change directories to that, and I hit CD and Tab on my keyboard to change directories really fast. Notepad ArrayList addAll.java will be the name of my source code file. And let's go ahead and paste this stuff in here. So let's come up here and save. Single class here, and here's my main method entry point. And basically everything, all this highlighted stuff here is what we've talked about. And let's go ahead and compile and run that. So let's clear our screen. Java C to compile it, and I just hit Tab to pull that up real fast there. The ArrayList addAll.java is what we want to compile. And now we'll type in Java, which will run the Java virtual machine, and we want to invoke the ArrayList addAll class. All right, so in the first one right up here, right, when we displayed this there, we get some of my favorite states: Alaska, Colorado, Kentucky, Ohio, Texas, Vermont. The next one there, after we invoke the addAll right here, we get our new stuff there with Delaware, Florida, and Hawaii. Basically inserted right in the middle of our array list. Okay, so fairly straightforward on that. Let's come down here. Now, in this next statement here, I am specifying the number class. Okay, and the number class, you know, I go over the number class a lot in primitive integer wrapper classes, like for example, double byte, all those ones there. And maybe I should just go ahead and pull that up there. So the number class has direct known subclasses: byte, double, float, integer, long, short, so on and so forth there. And all of these particular classes are just basically wrapper classes for the primitive int types, right? And they turn basically an int into actually a integer object there. Okay, so basically all of these are subclasses of number. Right, you can see extends number right here. So when I specify number here, we can add in the number class or any subclasses of the number class. Okay, and that is basically, coming back up to my website here, that is what this means right here. Okay, so number or any subclasses of number, which would basically be all of these subclasses here, including integer, float, byte, double, short, so on and so forth there, right? So that's my point on that. Let's go ahead and get this off screen again here. All right, so in this new ArrayList num list there, and you can see I've used the inferred type syntax over here by leaving this empty. That'll basically, the compiler will know that this is a number and all subclasses of that. And then I'm just going to invoke the add method and put in a new double 6.99 in there. And then I'm going to invoke the addAll, and using the arrays as list, I'm going to pass it these particular parameters to make my list. This will make a list object, remember? And list is a, well, no, list is a interface, but and list is a sub-interface of collections, so we can pass that basically in as the parameter there. Now notice auto-boxing. These will automatically auto-boxing to primitive wrapper objects, and this is where some of this stuff starts becoming really cool, because you notice like 7, you know that's an integer literal, 10.3 is a double literal, another integer, another double, 7.65f is a float literal. And then I'm just going to use an enhanced for loop to iterate through the num list array list. And we know that because we specified this up in the generic syntax as the number class, we can declare a number temporary variable here, n, right? And so n will contain all the values as we iterate through the num list array. And one of the other things here is the get class object. Now the get class method is actually inherited from object. So, and that's one that I haven't gone over with, but it's very useful. It's great. Now the get class method just returns the run class of this of the object. All right, and I'm going to show you how that works here, and it's another cool thing. So it's going to demonstrate a couple of different things here. So I'm gonna go ahead and just see if I can, let's move this code down here. Actually, let's move it, yeah, we'll move it kind of off to the side over here. So, yeah, maybe scroll down on this here. Yeah, right like that. That looks pretty good there. All right, so you can see in num list here, the first thing I added was a new double 6.99. So it says 6.99, and then basically as I iterate through this array list here, I'm displaying the value plus the string literal class type equals, and then plus whatever comes back from get class. And you notice 6.99, it'll come back, it'll say class java.lang.uppercase D is double there, right? So you can see that's the particular class that 6.99, that object inside of this num list array actually is. You can see 7, class is the integer, 10.3 double, 199 integer, 1400.999, that's a double. 41 is an integer, 7.65 is a float. So inside of this array list here, we have many different object types, but they are all derived from the number class. And so just to reiterate now, hopefully that should probably sign the deal on what this particular syntax means right here. Question mark extends E. Because I've got number passed in there, right? Any subclasses of number can be valid in this particular array list, okay? And just to drive the point home, the next thing I'm going to do is this runtime exception. I'm gonna make an EX list there, array list, right? And so I'm gonna add all and then arrays as list using that particular method there with the arrays class. New null pointer exception, new index out of bounds exception, new class cast exception, right? And then let's go ahead and display that. So you can see, there we go. We've got 3 different class object types, but they're all derived from runtime exception. If I were to try to say, like, put in here a new exception, which is a superclass of runtime exception, right? And let's go ahead and save that. We're going to get a compile time error. Right? And it just goes crazy there. No suitable method found for blah, 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 blah. You know, it's really talking about the exception right there. Okay, so that's basically, we can't even compile the program because all this stuff is type safe. So we're not gonna end up with like runtime errors and stuff like that because of incompatible classes and whatnot there. So that's really kind of the beauty of all this here. Let's go ahead and recompile this here. And, oop, did I save that? I have too many. There we go. Let's rerun this. Okay, so the last thing I'm going to do is just a little extra credit, right? The arrays as list, it's been around forever there, but we've also got this collections class up here, and I'm going to pull that one up here. Collections, it's really pretty cool, especially when you're dealing with the collections framework here. It has all of these static methods here, and it has addAll, right? But it takes 2 parameters. You can pass in a sub interface or subclass of the collection object, right? And then you can pass in elements too. Now you know that list is a sub interface of the collection, and ArrayList is a subclass of the list interface there. So we can do this, which is really pretty cool too here as well. We create our ArrayList, right? And it's just basically we're specifying string here. And then we can say as the first parameter here, strList, which is our reference variable to our ArrayList object. And then our next, and then basically we can pass in just a simple like array values to populate this here, blue, green, red, yellow, and orange, right? So we can do this all in one particular line here without creating a whole brand new object or anything like that. Okay, so that's kind of the extra credit on this, because I'm like, it's like I'm going over this topic. I might as well cover other ways of doing this rather than just arrays as list, that method here. The collection addAll there, right? Collections addAll has essentially kind of the same thing. You notice the, it's just coincidence, but whatever, they call the method the same thing there, so as far as that goes. But it's just probably not a coincidence, but it essentially does the same thing. So there, we've got blue, green, red, yellow, and orange in the str array list here. So that I'm going to go ahead and close out of this, leave you guys with some final thoughts here. The AddAll method is very useful for populating array list in bulk. In future ArrayList method tutorials, I will keep introducing more aspects of the collection framework. That concludes this tutorial. Thanks for watching.